Hi there, this is Sid and today we shall solve a SQL problem in StrataScratch. The title of the problem is The Cheapest Airline Connection. It's listed as a hard problem and the ID of the problem is 2008. As always, we shall start off by going to the input table. I have exported the input table to Excel since it's much easier to view it there. Once we have understood the input file, we shall come back and have a look at the problem statement. And after that, we shall try to solve the problem first in Excel, and once we have understood or formulated the strategy of solving our problem in Excel, we shall try to implement the logic in SQL. So let's start off by going through the input file first. So this is the input file. This is the airline fare table. The columns origin, destination and cost are fairly self-explanatory. So I believe we all understand the input table now. Now let's go back to the problem statement. The problem asks us to find the cheapest way of commuting from one source to one destination. That commute can be done either through a non-stop flight or through a one-stop flight or through a two-stop flight. But travels with stops more than two are not permitted. If we have multiple options of going from an origin to a destination, let's say there is a non-stop flight from the origin to the destination, and there is also a one-stop flight from the origin to an intermediate stop and then to the destination. How do we choose between the two? The way we choose between the two is finding out which costs the least, which is the cheapest. So that is our problem statement, fairly straightforward. You have been given an origin, you have been given a destination, find the cheapest way to commute from the origin to the destination. So in Excel, this is our input table. And here I have made an intermediate table which I call the one-stop table. So for example here, if you want to go from SFO to LHR, you have a stopover at JFK. So SFO to JFK, which costs $500, this line, and then JFK to LHR, which costs $1,000, this line. So the total cost of that flight will be $1,500. And I have done the same thing for all the other possible combinations. Similarly, you can have a two-stop flight. So to go from SFO to LHR, you can go from SFO to DFW, which is this line costing you $200. Then you can go from DFW to JFK, which is this line and will cost you another $200. And then you can go from JFK to LHR, which is this line, which will cost you $1,000. So the total cost will be 200 plus 200 plus 1000, that is $1,400. And just in case I missed, the total cost for the one-stop flights are also calculated by adding up the cost of the individual legs of the two flights. So now this combined table is nothing but a union of the non-stop table, the one-stop table, and the two-stop table. So for example, you will find one row SFO to JFK costing you $500 in the all combined table. So each of these rows will make an appearance in this all combined table. Similarly, each of these rows will make an appearance in the all combined table, and the two stop table's single row will also make an appearance in the all combined table. So in the all combined table, I have only kept the origin, the destination, and the total cost from the one stop and two stop tables. So columns F, I, and K and column M, R, and T have been added to this all combined table. So now we know how this all combined table is generated. Next, what I have done is I have taken this all combined table and sorted it by origin, destination, and cost. What that has done is, if there are multiple ways of going from the same source to the same destination, they have been clubbed together. So I have also added a color code to visually identify when we have more than one option to go from a given origin to a given destination. So if you have more than one option, then you select the one which costs you less. So between these two, you select the $400. Between these two, you select the $1,400. And between these two, you select the $300. The final output that is expected from us are the ones which are in green. So I hope at this point we understand how we are going to tackle this problem. So next, let's look at the SQL query. As always, I have written the SQL query in Notepad++ because it is much easier to see there. The first CTE that I have here is the non-stop flight. It is just the input table. I have simply omitted the ID because eventually I am going to do a union with the one stop and two stop options, and those will not have a ID. So apart from that, this is just our input table. The next CTE are the one stop options. And how is that CTE constructed? You take the input table and left join the input table with itself. So the first instance of the input table you call leg 1, the second instance of the input table you call leg 2. And how do you join these two tables? You say that the end or the destination of leg 1 must be the start or the origin of leg 2, which is very obvious, almost self-explanatory. And I have also included an exception here which says that the destination of the second leg of your journey must not be the origin of the first leg of your journey, because that would mean that you went from A to B and then you came back from B to A. Why would someone want to do that? And in the select clause, I have kept the origin of the first leg of the journey, the destination of the second leg of the journey, and the sum of the costs of the first leg and the second leg of the journey. So this is our first CTE. The second CTE is along very similar lines. I have taken the original input table, called it leg 1, and performed a left join with itself. The second instance I have called leg 2, and I have joined on this condition. The destination of the first leg must be the origin of the second leg. Now after that I have performed one more left join on the same input file. This time I call this leg 3, and I have said that the destination of the second leg of your journey must be the origin of the third leg of your journey. So this I think is not too difficult to understand, these left joins. And again I have a couple of exception clauses in the where clause to exclude meaningless options. For example, the destination of leg 2 and the origin of leg 1 must not be the same, because that would mean you go from A to B, then from B to A, and in the third leg you go from A to anywhere. But the first two legs are meaningless. Similarly, the second exception is the destination of leg 3 must not be the origin of leg 2, because that would mean that you go from A to B, then B to C, and then from C you come back to A. And the last exception clause is the final destination must not be the original origin. So you should not go from A to B, then B to C, and then from C come back to A. So these are the exceptions. So now that we have all the cities ready, all we have to do is union all these cities into one single table. Now I have to isolate those rows for which the fares are the lowest. So how do I do that? I use the window function row number, and I perform a partition over origin and destination. So this ensures that if the origin and destination are the same, then you assign a row number by the order of the total cost. The cost, you remember, is the total cost. So if there are multiple ways to go from one origin to one destination, then they will both be clubbed together, but the less expensive option will get a lower row number. For example, $400 will have a row number of 1, whereas $500 will have a row number of 2, and so on and so forth with the other multiple options of going from a given source to a given destination. So this is our last CTE. Once we have our last CTE, I have a simple select clause which says you select the origin, the destination, and the cost from this final CTE where the row number is 1. That ensures that you have picked up least expensive ways of traveling from a given origin to a given destination. So now that we understand the SQL query, let us quickly paste it in the StrataScratch editor and run the query. So we can compare this output with the output provided by StrataScratch. So for example, to go from SFO to DFW, the minimum cost is $200. SFO to DFW is $200. The next one is DFW to JFK is 200. DFW to JFK is 200. The next one is SFO to JFK is 400. SFO to JFK is 400. The next one is DFW to LHR is 1200. DFW to LHR is 1200. And the last output that they have included is JFK to LHR is 1000. JFK to LHR is 1000. So the output has listed only the first 5 rows, but I am confident that the others will also agree. So that's all for today. I'll keep coming back with solutions to more SQL problems from StrataScratch. For that, please stay tuned.